record. Okay. So I'll start with question number 5 first, right? So if you read this question, you see um, there are 288 voters in California, and 141 of them voted in the presidential election. And there are 216 voters in Colorado, and 125 of them voted in the presidential election. And the question is to construct a 95% confidence interval for the difference in the proportion of voting in California and Colorado, right? Okay, so for this question, you need to use one of these 4 different formulas that we learned last week. You may recall these formulas from last week. So this is the formula for the difference in population means when the variances are known. And this is the formula for the difference in population means when the variances are unknown but equal. And this is the formula for the differences in population means when the variances are unknown and not equal. And finally, this is the formula for the differences in population proportions. So of these 4 different formulas, which one do we need to use? Hello guys, talk to me. For this question, which one do we need to use? Can you hear me, by the way? Hello? Can you hear me? Yes. All right. So of the 4 different formulas, we need to use, because this question is talking about proportions, right? So the formula that we need to use is this one here, right? Do you follow me? Yeah, this is the formula that we need to use, okay? So that's what I'm going to show you how to do. So this is question 5 of the tutorial sheet 10, right? So the formula that we're going to use is x bar minus y bar plus or minus all right. This is the formula we're going to use, okay? So let me put this in let me put this in a box or something, right? Okay, now x bar corresponds to the proportion of waters in California, right? So x bar is equal to 100. There are 141 waters out of 288 in California. Y bar corresponds to the sample proportion of waters in um, Colorado, which is 125 out of 216. And M is the sample size for Colorado, which is 288, and N is the sample size for this is for California, and for N is the sample size for Colorado, which is 216. And we are looking for 95% confidence interval, right? Which means that 100 times 1 minus alpha is 95. So your alpha is 0.05, and your z1 minus alpha by 2 is at 0.975, which is 1.96. Okay, so this is everything that is given to us. We are given x bar is the sample proportion for California, y bar is the sample proportion for Colorado. These are the sample sizes, and this is the alpha. All you have to do is just put it in the formula. So if you put this into this formula, you will get you will get this. You get 141 divided by 288 minus 125 divided by 216 plus or minus 1.96. Then in square root, you have okay, divided by 288, right? Plus okay. Now if you do the math for this, right, you will get right. So this is the 95% confidence interval for the differences in proportions in voting between California and Colorado, right? Okay, so what this means is that since all these numbers are in the negative line, I mean this whole interval is on the negative real line, all right? It means that the proportion of voters in California is smaller than the proportion of voters in Colorado, right? That's what this means. Okay. Are you guys okay with this question or? Hello guys, talk to me, please. Before I go to the next one, are you okay with this? If you're not okay, please let me know. I'm happy to go over again. Okay. So that's question 5 of the tutorial sheet 10. Okay. The next question I'm gonna do. Is question. So I'm done with this. The next one I'm gonna do is question 4. So here you have two brands, brand A and brand B, right? And we are trying to compare. The means, the mean of brand A with the mean of brand B, and you are given all this data. You are given this data, and you are given this data. The question is to find a 95% confidence interval for the difference in population means, right? Okay. Now, okay, let's go back to the formula sheet. Now, which we have three different formulas for differences in population means. Which one do you think we should use for this question? And this is the formula when the variances are known. This is the formula when the variances are unknown but equal. And this is the formula when the variances are unknown but and not equal, right? So which one of them you think we should use here? Hmm? Hello, guys. The second one, yeah, exactly. Because the reason for that is because you see that it says that the two brands are normally distributed with a common but unknown value of sigma squared. This is the crucial wording, right? So you need to use the second of the three formulas, which is this one here, right? Okay, so that's what I'm going to do now. So I'm going to write it down. I'm going to write down this formula first. So this is question 4. So the formula I'm going to use is x bar minus y bar plus or minus right. This is the formula I'm going to use. Okay. Right. Now let's see what we are given. Okay, x bar is given to us as 21.8, right? And y bar is given to us as 18.9. And m is given to us as 12, and n is also 12, right? Now we need to work out sp squared. remember, SP is the sample standard deviation, right? We need to work out SP squared. Now, let me remind you the formula for SP squared is this is the formula for this is the formula I gave you. You should recall it. This is the formula I gave you for the pooled sample variance. Right? This is known as the pooled sample variance. Okay. Right now, let's see how. Okay, let's try to compute this, guys. So m minus 1 is 11. Okay, sx squared is the sample variance for the first sample, which is given to us as here 8.7 is, so it's 8.7 squared, right? Then plus this is also 11 times sy squared is 7.5 squared divided by m plus n minus 2 is going to be 22, right? Okay, so this is going to be 65.97. All right, so this is the sampled pool variance, right? Okay. Now so we got this. Now the only thing we don't have yet is this guy here. So let's try to compute that. M plus n minus 2 is 22. So we're looking for the percentile of a t distribution with 22 degrees of freedom. And we are looking for, and 1 minus alpha by 2 is, because we are looking for 95%, 1 minus alpha by 2 is 0.975, right? And this will be, if you read this off the table, this will be 2.074. Okay, so this is the percentile of the t distribution with 22 degrees of freedom and probability 0.975. All right, now all we have to do is now to put all the numbers into this formula here. Okay, so if you put all the numbers into this formula, you will get x bar, which is 21.8, minus y bar, plus or minus 2.074, times SP, which is the square root of this, times 1 divided by 12 plus 1 divided by 12. Okay, this is what you get. Right, and if you work this out, the interval will be from this to this. So this is the 95% confidence interval for the differences in population means for brand A and brand B. Okay. All right, guys, are you guys okay with this? Hello, guys, talk to me. Are you all okay with this or not? I mean, it's just a matter of working out which formula to use, right? I mean, you should get this is the correct formula to use for this question, right? So all you have to do is just work out every single element of this formula, like X bar, Y bar, and so on, right? And then put them in, and this is what you will get, right? Okay, guys, so that's question 4. You're done with question 4. The next question I'm going to do is question number 3, which is this one, right? So here you have 2 random samples, and that they are independent of each other. These are the sample means, and these are the sample variances. And you have 2 different estimators for two estimators, for one for mu and one for sigma squared, right? And the first part of the question is to show that both are unbiased. And the second, okay, let's do the first part first. Then we talk about the second part later on. Right? Okay. Okay, let's try to do the first part. Um, so you don't need to remember all these formula hang. The formulas you need to remember hang on the course website. You should go to the course website. Okay, let me show you if I can. Let's see. You should go to the course website. No, it's not here. I mean, I haven't opened it, but if you go to the course website, there's a link called the formulas you need to remember for the exam. So it's only like 1 or 2 pages, 1 or 2 pages long. So you need to remember only those formulas in that link, okay, and nothing else, right? Okay, let's do question 3 now. Question 3, part 1. You got this estimator, which is this is the estimator for mu, and we need to show that this estimator is unbiased. Now remember that to show that something is unbiased, you need to show that the bias is 0, right? Okay, so this is the expectation of okay, right? Now taking the expectation inside, you get this is what you get, yeah. Now, sorry, this should be n. Please stop me if you don't follow anything I'm talking about. Just please feel free to stop me and ask questions. Okay. All right. This is what you get. Now, if you take the expectation inside, this will be okay. Now we know that each of these expectation is equal to mu because the question says so. All right, so I'm going to replace this guy here and this guy here with mu, right? So this, and by the way, these two guys cancel. Okay, so this is going to be 1 over n plus m times the sum of mu. Okay, are you guys with me so far? Right. Then you have 1 over n plus m. The sum of mu I from 1 to n is n mu, right? And the sum of mu I from 1 to m is m mu. Okay. All right. And this is clearly equal to 0, right? Okay. So hence we have shown that mu hat is unbiased. for mu. Remember that an estimator is unbiased if the bias is equal to 0, right? And that's what we have shown. Okay. Are you guys okay so far? Thank you. All right. The next thing we need to show is you're not done yet. The next thing we need to show is we need to show that also sigma hat squared is unbiased, right? So let's see how we can do this. So this is question three, part one, right? We need to show that the estimator for sigma hat squared, sorry, the estimator for sigma hat squared is also unbiased, right? So let's see how we can do that, right? Now you're given the following. You are given the following estimator for sigma hat squared, which is this is the estimator for sigma hat squared, right? And now we need to find the bias. We need to find the bias of this estimator, right? In order to show that is unbiased, right? Okay, so this is gonna be the expectation of the estimator minus the parameter that you're trying to estimate. So this is gonna be the expectation of okay, like this, right? Now I'm gonna bring the expectation inside the brackets. So this is gonna be okay, like this. Now you may recall that way back at the beginning of this course, I showed you one of the results I proved in the class that the expectation of the sample variance is sigma squared. If you don't remember, please look back. Please look back in the very beginning. I think it's week one, week two, or week three. I can't remember right now. So if you look back, you will see that one of the results I proved in the class is that this is equal to sigma squared. Okay. Now if you simplify this, this is equal to 0, right? So hence we have shown once again that this is okay, it's an unbiased estimate of sigma squared. All right, guys. Are you following this? Okay. Hello, guys. Talk to me. Hello, guys. Are you okay with this or no? Yeah. Okay. Thank you. All right. The next part we need to show is part two. Part two is to show that the obtain an expressions for the variance of mu hat and say what happens when n and m go to infinity. So I'm going to do that now. So this is part two of question number 3, right? Now, you know that mu hat is this. Now we want to find the variance of this estimator. Okay. So this is gonna be the variance issue because this guy is a constant. You can pull it outside. Okay. Okay. Right now, because x bar and y bar are independent random variables, right? This becomes like this. Okay. All right. Now I'm gonna do the following. I'm gonna write this as the variance of okay, like this, right? Okay, and then I'm gonna take the variance inside the summation, right? So it becomes okay. All right, guys, are you with me so far? Okay, so these two guys cancel out. Okay. Now variance of xi we know is sigma squared and as given in the question. So okay, like this, right? And then okay, this guy is simply n sigma squared, and this guy here is m sigma squared, right? So this simplifies to, if you simplify this, the final expression that you will get is this, right? Okay, guys, so this as you can see clearly goes to zero as n goes to infinity or m goes to infinity, right? All right, so that completes part 2 of question number 3. Okay, are you guys okay with this? Okay, thank you guys, thank you. All right, so I'm done with question number 3. Now the next one I'm gonna do, so I'm done with question 3. The next one I'm gonna do is question 2. All right, so here you have, once again, you have two different brand A. There are 150 bulbs, right? Had a mean lifetime of this much and a standard deviation of this much, and 200 bulbs of brand B, mean lifetime of this much and standard deviation of this much. Find an approximate 95% confidence interval for the differences in mean lifetimes, assuming this and this. Okay, right. Okay, so this is, let's see how we can do this. Okay, let's see how we can do this. So for the first part of question 2, which form? Okay, let's return to this. For the first part of question 2, which of these formulas you think we should use? There are four formulas, right? This is the formula for the difference in population means when the variances are known. And this is the formula when the variances are unknown but equal. And this is the formula when the variances are unknown and not equal. So of these three different formulas, which one do you think we should use for part one? This I'm talking about part one, which is this one. Mm, Charles says variances are known and not equal. Because if you read the question, guys, it says it gives. Yeah, you're right. I mean, you need to use the first one because I mean the question clearly gives the standard deviation in each case. For the standard deviation for the first case is 114, for the second one is 98. So you need to use this formula here. So I'm going to use this formula to derive the 95% confidence interval. All right. Okay, guys, is that okay with all of you? So this is question 2, part 1. So the formula I'm going to use is x bar minus y bar plus or minus. All right, this is what we need to use, right? So now we need to figure out what is given to us. Okay, so let's go back to the question. Right, let's go back to this question. So we are told that x bar is the sample mean, right, for the first one, brand A, and it is given as 1386. Y bar is the sample mean for the second, brand B, is 1218. And we are told the sigma x squared. Sigma x squared is the sorry, sigma x, I mean, sigma x is the sample, is the standard deviation for the first sample, right? For the first population is given as 114. Sigma y is the sample, is a standard population standard deviation for the second, which is given as 98. M is the sample size for the brand A is 150. For brand B, it is 200. So this is everything that is given to us, right? So let's put this in a box. Let's put this in a box, right? So all I'm gonna do now is to sub in everything here into this box, right? And I will get the answer, right? So this is gonna be 138 minus 1218. Sorry, 1386. I mean 1386 minus 1218 plus or minus. All right. So, yeah, alpha is 100 times 1 minus alpha is 95%. So you're looking for 0.975, which is, if you read it off the table, is 1.96. So this is going to be plus or minus 1.96. Then in brackets, you have 114 squared divided by 150 plus 98 squared divided by 200. All right, this is what you have. Right now, if you simplify this, guys, this is what you will get. The lower limit will be this one. The upper limit will be this one. All right, so this is the 95% confidence interval for the differences in mean lifetimes for brand A versus brand B, right? Are you guys okay with this? Hello. Okay, thank you. So that's part A. Now, sorry, part one. I mean, part one. The second part of the same question is asking you, if you assume that the two variances are equal, how would you do this? If they are equal, so this is question two, once again, part two, right? So in this case, you need to use this formula here because this is the only formula where we can assume that the variances are equal, right? So we need to use this formula here, okay? So let's see how we can do this. So the formula I'm going to use is this one. Right, this is the formula I'm going to use, right? And now what I'm going to do is, because you should go back to part one. You should go back to part one. Use part one of this question. It says that M is the sample size for the brand A, and N is the sample size for brand B. And they are both pretty large, 150 and 200, which are very large numbers. I mean, in statistics, anything above 25 is considered a large number, right? So using a property that I mentioned earlier, I don't know whether you guys remember this or not. Using a property that I mentioned in the class on the t distribution, you may recall that if the t random variable approaches the standard normal as the degree of freedom approaches infinity, right? So we can approximate this. We can approximate this by this because of the fact that using the fact okay. All right, guys. 2-1 again. 2-1. You want to look at 2-1. Sorry, 2-1. Just a minute. Just give me a sec, guys. Let me show you 2-1 again. This is 2-1, yeah. Because in 2-1, we use this formula here, right? Because we are assuming that the population variances are known. I mean, the reason for assuming the population variances are known is once again the fact that the sample sizes are large. You see, the sample sizes M and N are pretty huge numbers, 150 and 200, which are, I mean, in statistics, they are very large numbers, right? Anything about 25 is large. So you can approximate the sample variances. I know you may think that these are actually sample standard deviations, right? Okay, but these can be taken to be population standard deviations too because of the large sample sizes, right? Okay, So when the sample size is large, you can approximate the sample standard deviations by the population standard deviations, and hence use this formula. Number one, I mean, hence use this formula instead of this formula here, right? Right, that's because when we have big numbers for m and n, so you can use this instead of this because this is easier to use. You see, guys? Does that answer your question, guys, or no? Okay, thank you. Right. All right. So let's get back to part two of question two. Right now, what I'm doing here, guys, is that because the m plus n minus 2 is a large number, you can approximate this guy by this guy, right? This is the percentile of t. This is the percentile of standard normal. And this is a property I mentioned earlier on the video on t distribution, right? And also SP squared. Remember, SP squared is this is the definition I gave you earlier. This is okay. This is the definition. Now, if you work this out, m is 150, so it's going to be 149 times 114 squared plus n is 200, so it's going to be 199 times 98 squared divided by m is 150 plus 200 minus 2, right? Now, if you simplify this big number, you will get 11056.32, right? Okay. All right. Now let's getting back to this formula here. You should sub in the numbers. X bar, we know X bar from earlier, right? Which is 1386. Y bar is 1218. Right, plus or minus z1 minus alpha by 2, we worked out earlier, which is 1.96. And SP is the square root of this, which is going to be the square root of 11056.32. And then this guy here, which is okay. This is what you get, right? Now, if you simplify this, right, the 95% confidence interval that you will get is right. So this is the 95% confidence interval for the differences in means lifetimes of the two brands A and B, right? Right, guys? Are you okay with this? So the only the tricky part with this part, this is 1218. Okay. The only tricky part here is instead of reading this, which is can be complicated, I approximate this by this. And you can do that because m plus n minus 2 is a large number in this case. So you can approximate the t percentile, the t random variable by the standard normal random variable. So this approximates to this. Right? All right, guys. So and also in part one, just to reiterate, in part one, because m is large and n is large, right? Because m and n are large numbers, Imogen, yeah, you can approximate for anything above 25 Imogen. So in this case, clearly m plus n minus 2 is much larger than 25 because remember, m is 150, n is 200. So m plus n minus 2 is 348, which is a very large number, right? Okay, and also in part one of question two, because m and n are large, you can take sigma x to be approximately equal to the sample standard deviation, which is 1 on 4. And similarly, you can take sigma y to be approximately equal to the sample standard deviation, which is 98. Right? So hence you can use this formula instead of formula 3. Right? Okay, guys. So this is completes question 2. Right? So the only question I haven't done yet is question 1. So I'm done with question 2. Question 1 is, well, let me see if I have time. I should, well, I've got a couple of minutes. Mm. 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 I should be able to do, okay, to do question 1, I mean, to do question 1, um, you have a random sample from a Bernoulli. This, remember, this binomial with parameter 1 is Bernoulli. The last page, you mean the last page of this one here, man? Do you mean this one, Defin? Yeah, this is the last page. I mean, okay, right now to do. I think I run out. I'm running. I only got a couple of minutes to do question 1, but this is really trivial because at least I can do the first part if you want me to. Um, so I will just do the first part of question 1. Um, it's basically asking you to remember from last week. From last week, you may recall this is the formula for the confidence interval for the proportion. This, all right. I hope you remember this, right? Okay. So the width of this interval, is x bar the upper limit, which is this. This is the upper limit, right? And the lower limit, which is this is the lower limit, right? So if you take the difference, the upper limit minus the lower limit, this is what you will get. You will get 2 times okay, this is what you get, right? And this is clearly proportional to x bar 1 minus x bar divided by n. And this is what part 1 is asking you to do, part 1 of question 1. Uh, and part 2 is really easy. It shouldn't be difficult for you guys. Anyway, I will post the solutions to all 5 questions on Thursday of this week. So you will see three types of solutions: the video solutions, the typed solution, and the handwritten solutions for all 5 questions on this tutorial sheet. Okay, guys. So have a great day. And once again, I really apologize for the problem I had with the review session today. My computer gave me a lot of trouble this morning. I couldn't get it working. So I had to borrow somebody else's computer, which I'm using right now. Okay, so I'm once again really apologize for the trouble with the review session earlier today. Okay. Okay, guys, have a great day, and please feel free to contact me 24/7 for any help you need. You know my phone number is 01612732941. You can also contact me by email or Skype or Zoom. Okay. Take care, guys. Bye.